Homework 5 for Math 114 is a Test 1 review. So we're going to review through Test 1. There are 37 questions. We're going to finish them up here together. First up, in the following situation, we want to state whether two variables are related in any way and in a way that might be described as a function, and if so, which one is the independent and which one is the dependent variables. Okay, so independent variable and dependent variables. Reminder that independent variable is our x usually, and dependent variables are y if we're using x and y as our stuff. So let's look at a situation here. You have an expensive phone bill and you want to know how the cost of the bill depends. Okay, well, they kind of gave it to us here. They said depends. Okay, so that means we're going to definitely have an x and y relationship. There's a dependent. So it says the cost of the bill, that's one part, depends on the time you spent. Okay, so which one is causing which? So which one depends on which? Okay, so the dependent variable is the one that depends. So we say the cost depends on the time we spent. So in that way, it's actually telling us the dependent variable is what depends. Okay, what does it depend on? It depends on the independent variable. So this would be a function, and it would depend on the amount of time you spend on the phone. So time on the phone is our independent, and the cost is our dependent. Prorate the following expenses to find the corresponding monthly expense. Okay, this is to say prorate means that even if we don't have to pay a bill every month, it's good to set aside that money each month. Okay, and that's the way we prorate expenses. So for example, if we pay a semi-annual premium of $550 for automobile insurance, that means we only pay it every 6 months, but we might want to set aside how much it costs. So the first thing we have is $550 per 6 months. So I'm going to divide that by 6. The next thing we have is a monthly premium of $175 for health insurance. So that we don't need to divide it all. It's already in monthly. And the last thing we have is an annual premium of $500. So we don't have to pay $500 a month. We have to pay $500 every 12 months. And so that would be how we go ahead and get our answer. But make sure we round to the nearest cent because we're dealing with money. When we look at this question, it can be more overwhelming, but it's not super complicated what they actually want us to do. So they're asking us to fill in the table with the numbers from the problem. Now they give us 123 pieces. It's increasing by 123 pieces per year. The fact that it says per year means I'm going to multiply by year. It also says that it started at 1182. And so they already used the 123. The 1182 actually goes over here because we need to add that to whatever number we get because that's what we start with. And so we're going to put the 1182 as our intercept right over here in our formula. However, they've already used the 123, so the question becomes what goes in this blank? And in this blank, we actually are just going to use the number they give us in the table. 0, 1, 2, 3, 4. Now, the bottom blank, it will get bigger if we're typing it in, but what we need to put in here is all of the pieces from above. So parentheses, 123 times t, close parentheses, plus 1182. Then there's a second part. It asks us to evaluate the expression for t equals 8. So we just plug in 8 and we get that number, okay? But what's confusing to people is that number is going to go in 2 places. And then when they say in blank, they're talking about the year. Now, the year is not year 8. The year is 8 after 2005. So it's actually going to be 2005 plus 8 is 2013. Use the 4 basic rules of algebra to solve the following equation. Don't get bogged down by that terminology. All that means is, hey, don't break the laws of algebra. Don't break the rules. And so what we're going to try to do is make sure basic rules of algebra say if we do something to one side of an equation, we do it to the other. So this is something that's squared. So the first thing we're going to do is we're going to work outward. So we're going to kind of peel away the outer layers as we work our way towards the inside. And what we're trying to get is the y by itself, or y equals. So we're going to start by square rooting both sides. But it's not quite that simple, because when you square root both sides, it does cancel out the exponent that was squared, but we actually end up with a plus or minus on the other side. Okay, so don't forget, whenever we square root, we always have to have a plus or minus. Now when we multiply by 2, we end up with y equals 10 or negative 10, either one of those. And if we were to plug them back in, you could see that if we plugged in 10 or negative 10, they would both give us the right answer. Calculate student loan of $15,000 at a fixed APR of 6% for 20 years. Okay, so we start with $15,000. That is our principal. We have an APR of 6%. Now, if we were to convert that to a decimal, I want you to understand that it's growing, or is it shrinking? And so we have an APR of 6%. We need to think about that in decimal terms. And the last thing we need is time. The time is 20 years. But I want you to notice what we're trying to solve first. The first thing we're trying to solve is monthly payment. Monthly payment. So a few things we need to do before we can solve our problem. The first one is to recognize that there is an Excel formula for this. You're allowed to use Excel in this course. So it could save us some time to go in Excel and type equals. Now our equals here, I believe, is PMT, because it says calculate the monthly payment. Okay. Now, to calculate the monthly payment, we need to do a few things. One, it's going to ask us for the principal value. The principal value is our 15,000. Don't put it in with a comma, or it'll bug out at you. It'll also ask you for the percent, and it'll also ask you for the N per, which is the number of periods. Now the number of periods, that one is going to be not just 20 years, but 20 times 12, because we're not getting the annual payment, but the monthly payment. So it's actually going to be 240. The same logic, when they ask for us, they don't say, what's the APR? They say, what's the rate? And what they're talking about is the rate for each month. It's not 6% per month. It's 6% divided by 12. Okay, so when we go to type this in, and we type in the rate, the N per, and the PV in our PMT function, we want to make sure that we're using the consistent amount in months. So we need to divide the rate to make it into monthly, and we also need to multiply by the number of months there are in a year to make the total number of payments. If we knew that the total amount we'd pay each month was a set amount, and let's just say, for hypothesis, it's $200, okay? If we wanted to find the total amount paid over the loan, if this is our monthly, then all we'd have to do is multiply it by however many payments we're going to make, which in this case is 240. And the last thing it would ask is the percentage paid towards the principal and the percentage paid toward interest. So what we're going to want to do there is we're going to want to make a fraction of paid towards the principal compared to the original. And so on the bottom of our denominator, we're going to put the 15,000, and then whatever our total here is we're going to put the total on the bottom, which is going to be whatever we got there for part B, and then the principal was 15,000. Well, how do you know the interest? Well, it's still going to be out of the total, but the interest we're going to have to take the total and subtract what we started with. Okay, I would use Excel. That's just me personally, but there's also formulas that you can use for this. Okay, so check your notes on which way you prefer to do this problem. Write a short statement that expresses a possible relationship between the variables, a size of a diamond, and the cost of a diamond. Okay, so the first question I have for you, okay, is which one comes first? Do you pick a price, or do you pick a size? Which one comes first? Well, the truth is, what's causing the other one? The size of the diamond is not something you change based on cost. The size of the diamond is our independent variable. The cost of the diamond depends on how big it is. That's one of the things it depends on. So what we can say, if we were to just kind of generally say it, as the cost goes up, the size also goes up. Now, if we put that, that is not the best possible answer, okay? The cost goes up, the size goes up, because we put it in the wrong order. The independent variable should come first. So the better answer is to say that as the size goes up, then the cost goes up. Now, to be fair, there's actually a flip way we could do this, right? We could do one more version. We say as the size goes down, then the cost would go down. They're in the same direction. So even if we said down, it still is a mathematical relationship. Identify the independent and dependent variables and describe the domain and range. Okay, so first off, the independent variables are always our x value. It's also going to be where we look for domain, which means we have our dependent variables are our y values. Which means it's going to be where we look for our range. So let's look at how we'd actually say what our domain or range would be. So our domain would be, let's see, what possible value do we have for the domain? Well, we have the numbers 1950 and up until the year 2000. And I use square brackets, I use that notation, but I'm really just saying all the years between 1950 or 2000, that's what we're talking about here. The range, what we're going to do is we look on the left side and we say, where's the bottom and top of this? Okay, and it looks like it's about 2.2 billion, and it goes to about 6 billion. Consider this data. So we have this graph, and this is bar charts. Now, it's bars, unlike a line chart. It means we just have each of these are representing separate categories. And in this case, our categories are different countries. We also have, these are a side-by-side bar chart, so we have two groups in each country. In this case, boys and girls. Okay, so let's look at the kind of questions they ask us when we look at this that we want to be able to analyze. The first thing we want to look at is if we were to notice, it says that the bar graph from country E is more than twice as long as the bar graph from country D. So let's look at what that they're saying there. They're saying country E, for the girls, is more than twice as high as the bar for D. Does that mean they scored twice as high? So does that mean they scored twice as high? Well, let's take a look at what the scores represent. If we would continue this bar and look over here, is 540 twice as high as, I don't know, 490? No, it's not. So why is it not true that E is scores twice as highly as D? Why does it look like it is when it's not true? And that's because the axis, okay? So it doesn't start at 0. Y axis doesn't start at 0. Okay, so that's a big problem with the way we look at this graph. If we were to zoom out and put this starting at 0, these numbers are actually pretty close together. It's not nearly as spaced out as it might look when we're zoomed in right here. Part B says, assume that the data in the figure represents overall regional differences in performance. Okay, so the ups and downs are supposed to say, yeah, are we showing something consistent? So, and it says, imagine that country G is right next to country F. So we have F and G is in the same region as, suppose country G is in the same region as B and F. So it's actually in B and F. So I'm looking at B and F. And I want to see what would I expect for the boys and girls to score in G if they have the same results as we saw in B and F. Well, what happened in B and F? Well, the boys and girls both scored pretty well, and the girls scored better. So I would expect in G that the girls would score a little better. When we're looking at data in a table and we need to convert it to data in a graph, we need to be able to choose the data table and graph match that makes the most sense. Okay, and so let me give you an example here. This example, we have years as our dependent variables, so that's along the bottom, and you'll see that that's actually true, right? It's along the bottom of both of these. Both of them are years. Okay, and then we also have a median age, and both of them say median age. So I want you to notice first off that the data is right. You don't need to go zooming in here. Obviously, we can see that out of these two, the data is right. And so that's the first thing you need. If you're going to have a good graph, it's got to be the right data. Okay, obviously. The other thing we got to watch out for is, did we pick the best graphical display for our data? And if we have years on the bottom, if we have years, or if we have time, we're going to usually use that right there. So if time is our independent and we're showing a change over time, we generally don't use bar graphs. Okay, so the question would then be, well, when do we use bar graphs? Because I feel like a lot of times we use time as our thing. Well, we use that when we have categorical data. In other words, is our independent variable, or is our x a category? And in this case, it's not really a category, it's a time. So it's showing, it's a number, it's quantitative. But if I had to split it up into, say, different groups from different countries or from different teams, then those are different categories, not the same group across time. Compare A and B in 3 ways, where A is 1.6. So we're writing ratios here, and it just tells us what to do, except when we're writing ratios, we generally write them as percents or fractions. There is that ratio where we have a colon, the 2 dots, like it looks like it's a time, right? But we're going to go ahead and write these ratios as fractions in this course. So when we say ratio of A to B, what we're saying is put A over B, okay? And so all that needs us to do is type in 1.6, and I can not even type the million. I don't need it because they both have million, and 2.3. If I were to type million on the top and bottom, it would cancel out anyway. And then that would be my answer for part A. For B, however, I need to flip it upside down because it says ratio of B to A, so B has to go on top. 2.3 over 1.6. And the last part says A is what percent of B, okay? So A is what percent of B means we take that ratio from part A and we turn it into a percent. Now, how do you convert this fraction, this ratio, to a percent? Well, all we have to do is type it into our calculator, get the decimal, and then multiply by 100, or move the decimal place too. The price of oil recently went from $7.20 to $12 per case of 12 quarts. Find the ratio of the increase in price to the original price. Okay, so it says the ratio of what? The ratio of the increase in price to the original price. So I've got 2 things I need. First thing I need is the increase in price. So what is the increase in price? Is the increase in price 12? No, that's the new price, but that's not the increase in price. So the increase in price is going to be when we subtract those. So the increase is 12 minus 720, or 480. So that's our increase in price. So that's the first part. It also says it's the ratio of the increase in price to the original price. Now, our original price was 720, so we're just going to write this up just like this. And now we have our answer. Find the missing number in the proportion. So I'm going to solve this proportion. I'm trying to get the x by itself. So I'm going to multiply both sides by 9. And that means I'm going to get 72 over 3 equals x. Divide 72 by 3, and I get x equals 24. And so our missing number is 24. Now, some people do the cross multiply and divide, and so that's going to be the same thing. Make sure you solve for that x. Nearly 5 out of 6 people choose vanilla. 5 out of 6 choose vanilla as their favorite ice cream. Now, if 156 people attend an ice cream social, how many would you expect to choose vanilla? Now, choose vanilla, that's our question mark. Choose vanilla. 5 was also choose vanilla. So we put vanilla on the top. On the bottom, I'm going to put the total. Out of 6, okay? So out of 156. And so what we can do is we can solve this proportion now by cross multiply and divide. Just like that. So we're going to say 5 times 156 divided by 6 equals x. And we can go ahead and type in our calculator here. I'm going to go ahead and type it in my calculator just to make sure. And so I do 5 times 156 divided by 6. And then we make sure we say, how many would you expect to choose vanilla? And we get our answer. At 3 p.m., Coretta's shadow is 1.43 meters long and her height is 1.85 meters. At the same time, a tree's shadow is 7.73 meters long. How tall is a tree? Now, to solve this problem, we have to represent, yes, it's at the same time, and we're talking about shadows, so let's assume they're at the same place. It doesn't say that. And this is a classic way that they found the circumference of the Earth. What they noticed is that when you have the sun casting shadows, each of the shadows make a similar or proportional shape, okay? So that's to say that each one of those ratios should be the same. So if Coretta's shadow to her height is 1.43 over 1.85, then that should match, that ratio should be equivalent. It should be proportional to the tree shadow. Now the tree shadow is 7.73, so I'm going to put that on the top because that's where I put Coretta's shadow. And it says how tall is the tree? In other words, what's the tree's height? I'm going to put an X right there. And all we're going to do is we're going to cross multiply and divide to find that answer, just like we'd solve any other proportion. Suppose y varies directly. It says directly with x. So first thing I need you to know is that a direct variation always goes to the point 0, 0. So first off, we know there's a point 0, 0. We also know there's a point 6.3 for y when x is 0.9. So that was a bit tougher to graph. 6.3, I'm gonna go up there, and 0.9. So that'd be like right here. Okay. Now, if I'm doing this on the computer, it probably won't let me just put a point wherever I want. Okay. So direct, that is a terrible line. See, what I'm having trouble here is because I know two things about direct variation. I know that it goes through 0, 0. That's one thing. And also it's linear. It's a straight line. So I'm going to use this to find my slope. And then my y-intercept, where does it cross the y-axis? At 0. So my equation is going to be y equals, and if I simplify that slope and divide both of them by 0.9, I get y equals 7x. Now that's much easier to graph because I start at 0, 0, and I just go to 7, 1, or 1, 7. The distance for an object that falls directly as the square of the time. Distance of an object, so we have a couple things here. That's telling us our formula right up front. It says the distance, that's d, varies directly, so kx, but it doesn't say varies directly with x. It says varies directly with the square of the time. Okay, so rather than just put x, I'm going to need to put the square of time. So I'm going to put t squared. So they've given us a formula to use. They then tell us the situation. They say if an object falls for 3 seconds, so that's situation 1, says t equals 3, then it says it will fall for 144.9. So we can say d equals 144.9 feet. Now it says to estimate the height of the cliff, a person drops a stone at the edge of the cliff and measures how long it takes the stone to reach the base. If it takes 3.7 seconds, what is the height of the cliff? So our first situation they give us here, and then our second situation they say, they don't give us quite as much. They just say the t. They say t equals 3.7. What is the d? Okay. Now, to solve this problem, we need to remember that we have three things in this variation problem. We have the d, the t, but we also have the k. And so to find our k here, we're going to need to plug in the two things we have and solve that equation for k. So if we do that, what we'd end up getting is 144.9 equals k times 3 squared, or 9. Then we're going to divide both sides by 9, and we get k equals 144.9 divided by 9. Okay, so that right there is our k. I'm going to leave it as a fraction just for funsies. You might want to clean that up and try to actually do the division, but I'm just doing this by hand, so I'm going to leave it just like that. So now that we have a k, it's the same k in the other one. So if we have two unknowns, or two knowns and one unknown, all we have to do is plug that into the same formula. So we'd say, well, we're going to plug in the t that we have and the k that we have, and that will give us our d. Company XYZ closed at $99.86 per share with a PE ratio of 10.91. So PE ratio, it says P divided by E equals 99.86. Now, they also told me the P. Did you notice that? They gave me the price. So P is the price, so we're going to put 99.86 right there. And what they want to know is what were the earnings. So to find E, I just need to solve this equation. So I'm going to go ahead and do that by multiplying by E and dividing. So E, oh, I wrote the same number twice. Please forgive me. The PE ratio, I put 99.86, but the PE ratio is only 10.91. Okay, so to find E, we're going to need to swap out that, and we're going to get 99.86 over 10.91, and that is our earnings per share. Now the next thing it says, does it seem overpriced or underpriced or about right, given the historical PE ratio is 12 to 14? So the PE ratio right here, does that fit in there? No, it does not. That actually is too low. So we're going to say it's underpriced. A group of people win a total of $10 million. Now it says we're going to write a function, f of n, for how much money each person is going to get. Now, if they win $10 million and there's n people, then our function is just 10 million divided by n. So if there's 10 people, they each get 1 million. If there's 5 people, they each get 2 million. Now, this is a pretty basic variation equation, and we can even say the variation constant, k, well, that's just 10 in this case. The weight m of an object on the moon varies directly. Yay! Varies directly. So m varies directly. So I'm going to say k times x. Well, it doesn't say k times x. It says k times e. Okay? So the first situation they give us is they tell us the weight on Earth. They tell us in situation 1, they say the weight on Earth, E, is 153.82. And then they tell us the weight on the moon, so that's M, is 26.15. Our second situation, what do they tell us? Well, they tell us that an Earth weight. They tell us E, 218.24. What they want us to find is the M. Okay. There's something missing though, right? When we have a direct variation or an indirect variation, a variation problem, we know the basics of the formula, but that means we need to find the missing piece. In this case, the missing piece is the K. In order to find K, what we're going to do is we're going to plug our M and our E back in. And so we're going to get 26.15 equals 153.82 times K. And so we're going to divide, and so we get K equals 26.15 over 153.82. And you can type that in your calculator and try to clean that up. I'm just going to leave it just the way it is. Now, the nice thing about this is that since we have one formula, the K is called our constant of variation. So it is a constant. It doesn't change like our variables do. So we can use the same K right here. Which means to solve our problem and find M, all we need to do is go in and set up our equation. M equals 2615 over 153.82. And then we also have our E that we're going to plug in. The pressure exerted by a certain liquid at a given point varies directly. So it says the pressure varies directly. So I'm going to say P, pressure, varies directly means I'm going to say P equals K, because we always have a P equals K when it varies. But since it varies directly, I'm going to multiply by the depth. That next part, it says varies directly by the depth. So the first part, we write the equation. The second step is to take situation we know, pressure and depth. The pressure at 50 feet, so we have 50 for our depth, is 300 pounds per square inch. And so our first step is to write the equation. Our second step is to plug in two known measured values. The third step is to solve that for our K. And so we can divide both sides by 50 and we get K equals 6. The next step would be to try and write our equation with K, except with the number we just found. And then the last step is to plug in our situation that they want to check. It says find the pressure. What is the pressure at 30 feet? So I'm going to say P equals 6 times 30. And so our pressure is 180. Company XYZ closed at 99.86 per share with a PE ratio of 10.91. So PE ratio, it says P divided by E equals 99.86. Now, they also told me the P. Did you notice that? They gave me the price. So P is the price, so we're going to put 99.86 right there. And what they want to know is what were the earnings. So to find E, I just need to solve this equation. So I'm going to go ahead and do that by multiplying by E and dividing. So E, oh, I wrote the same number twice. Please forgive me. The PE ratio, I put 99.86, but the PE ratio is only 10.91. Okay, so to find E, we're going to need to swap out that, and we're going to get 99.86 over 10.91, and that is our earnings per share. Now the next thing it says, does it seem overpriced or underpriced or about right, given the historical PE ratio is 12 to 14? So the PE ratio right here, does that fit in there? No, it does not. That actually is too low. So we're going to say it's underpriced. Suppose you need $3,000. Now this has a CPI formula, and it wants to know if we are buying a car and the car prices increased at the rate of inflation, how much money would it cost to buy the same car? So in other words, what would a $3,000 buy us in 1976 in 2012 money? So we're going to go to 1976. We've got a CPI, and we're going to go to 2012, and we got a CPI. And what we're going to do is we're going to take the CPI, and we're going to recognize that if everything should be proportional, I'm going to make sure I set it up so that I have it, all the prices match up. So this one is going to be my old number, my 1976 number on bottom. So in 1976, that's where I'm going to put the 3,000 on the bottom. What I'm looking for is my X, or my dollar amount that scales up. And so we can cross multiply and divide and solve this like a proportion to find X. The average price of a low-fare airline ticket rose from 240 in 1991 to 440 in 2006. So we're calculating the relative change in that price. Okay, so first off, how much did it increase? Relative change, we need to take into account how much it increased. Well, it didn't increase 440. It didn't increase 240. It actually increased $200. Okay, that's the increase in price, because I subtract what I ended with from what I started with. And then I need to divide it by my original price. So if I type that in my calculator, I get 240 divided by, sorry, other way around, 200 divided by 240. I get something like 83%. Okay. So the next thing it asks me to do is to compare it to the overall rate of inflation as measured by the Consumer Price Index. Okay, so the Consumer Price Index is this table here on the right, and what it shows us is that we can pick years and see what the normal inflation was for those years. So the years we're talking about is 1991 to 2006. Okay, so it did go up. So we're going to use our formula where we take the numbers we have there. I'm going to use purple. And on the bottom, we know that we want our original number. So our original number was 136.2 in 1991. By 2006, it had risen to 201.6. So we're not just going to write 201.6 on top. We need to subtract what we started with, 136.2. Okay, and so if we type that in, we should be able to get another percentage of increase, right? It should be similar to what we saw with the ticket prices. So let's try it. As a fraction, we can go ahead and write 201.6. I'm typing in my calculator. That's why I'm saying it out loud, to make sure I type in the right thing. One of the most frustrating things is when you do a problem correctly and then type it in the calculator wrong. Oh, that's just the worst. Now, when I type that in my calculator, I got 0.48, or 48%. Okay, so guess what? The overall inflation rate, it went up 48%, right? But the ticket prices went up even more at 83%. When we look at this figure, what we've got a few things in this problem, and I don't want to get too bogged down on too much of it. So I want you to notice that we have a fixed monthly income of $3,500, and it also says that this couple spends $690 per month on healthcare. Okay, so is that average? Well, we can calculate what percent of their income that is, right? Because we could say out of their $3,500 total, they spend $690 on healthcare. So we can find out what that would be. And that looks like it's about 20%. Okay. Or if I wanted to be consistent with the table, I might do one decimal place. So that would be 19.7%. Now, if you look at the table, the question is that normal? And so we look down and we find healthcare. Healthcare is right here. And we pay attention to the fact that there's three different ones there. They're actually above all three of them. but I want you to notice they are 65 and older, so we should expect them to spend more than someone who's young, but they're above that 12% right there. Let's just define and distinguish among mean, median, and mode. So first up, mean is the average, okay? Now there's a few different ways we talk about mean, but the big one is to just say we're finding the average, and that's actually our formula. If we're in Excel, we say equal average, and it'll calculate mean. And we just put the numbers we want. The second thing we need to know is the median, okay? Median is the middle. And if we're using Excel to find the median, we don't have to put them all in order and then find the middle number, because there's a formula. It's called median. So we type in equals median and then type in the numbers, or we can select the numbers, the cells that the numbers are in. And our last category is mode. Now mode is the one that occurs the most, okay? So whatever number happens the most is our mode. So if they all tie, we might see if there's no mode, but there's actually a formula, and I'm going to let you guess. It is mode, equals mode, and then we put the numbers in here. I want to give you a warning that there's probably a couple versions of mode in Excel. Just know that that's meant to represent whether or not it counts ties and how it deals with ties, okay? So our default is just equals mode, and what we'd say if there's a tie and they all tie with having just one, we'd say there is no mode. But if there's a couple of them that tied to have the most, then we'd write both of those as our mode. What do we mean when we say that the distribution is symmetric? Okay, symmetric means that both sides of the distribution react the same. We expect to have some low numbers, some high numbers, and about the same distribution on either side. That's what symmetric means. So an example of that would be the heights of 100 women. Now, we can assume 100 women, let's assume we have an average height in the middle, that most of the women are about average. There are going to be some short ones and some tall ones. Okay, so on either side of average, we're going to have some symmetry. I wouldn't expect the average height and then there to be a bunch of people that are like 10 feet tall. Like that would be an extreme situation. If my sample of 100 women includes professional basketball players, then it might look a little different, right? The speed of cars on a road, however, would not be symmetric, because if we have a visible patrol car and we had a speed limit, let's say the speed limit was the average speed people were going, there are going to be some people that are driving below the speed limit, okay? So if the speed limit was 60, there's going to be some people that they see the patrol car and they're going to drive 55. Okay, but most people are going to drive around the speed limit if they see a patrol car. There are going to be some people that are going to be driving too fast. And so we're going to have a skew to the right. This is going to be right skewed, because in the positive direction, there's going to be some people that are driving like 80, well above the speed limit. What we're not going to see is people that are driving well below the speed limit. On the highway, you're not going to see people driving 40. That's unsafe. That's against the rules. But somebody driving 80 would not be able to slow down maybe when they see that patrol car. We might see some people that are skewing it right. So because we have some extremes that are on the right side, we call that right skewed. Another example of skewed data might be the number of books read during the school year by fifth graders. So let's say the average fifth grader reads about 10 books. There are going to be some fifth graders that only read 7 books. There's going to be some that read 13 books. And so it's pretty symmetric, except for the fact that there are going to be some fifth graders that read 0 books. That's true. And there's going to be some that read 20 books. But this is actually going to be right skewed. And the reason is because there's going to be some fifth graders that read 100 books. There are some fifth graders that are going to read way more than average. And so this is, again, going to be right skewed, because there's going to be some extremes on the right side. There's not going to be extremes on the left side, because we're limited on the bottom there. We're limited by that 0. So we can't go extreme left. People can't read negative number of books. Now, if I told you the distribution of grades was left skewed, but I told you that the mean and the median and the mode were all the same. What we need to recognize is that mean, median, mode are measures of central tendency. And so if we have a distribution of grades, since we're talking about grades, I'm going to make a little bell curve, okay? And if I told you that the mean was right in the middle, and if I told you that the median was right in the middle, and then I also told you that the mode was right in the middle, then you would probably expect it to be symmetric. Okay, now when would it not be symmetric? Well, we could also have something left skewed. Now what left skewed means is that the tail is longer on the left. So I'm going to show you a situation where the tail is longer on the left. This is left skewed because it has a long left tail. So in this case, I would say it doesn't really make sense to have the middle in all three of those be the same, because as we were to pull the tail in one direction, that's going to have an effect on the mean, median, and mode. Mean, median, and mode are three different things we can solve for. Now, rather than just type these numbers in formula and show you how to work them out by hand, I want to try to help you as much as possible with how we type them in Excel. So the first one is for mean. There's no mean formula in Excel, but we use equal and then average. And then we just put our numbers in that formula. For median, the formula is equals median. Pretty fancy. And then put our numbers in there, and it'll give us the median. And the last one, it'll be mode, and our formula is mode. Okay. It might give us an error on mode if there is no mode. So I want you to notice, if we were to look at this, mode being the most common, so it might be no mode, which it is in this case, and it might give you, depending on which Excel version you're using, a different formula, a different result to your formula, but it'll probably say something along like NA or error here, because in this case, all of the modes tie. They only happen once. Describe the process of calculating a standard deviation. So I'm going to tell you, I honestly, for standard deviation, I don't like to calculate by hand. We could certainly do it, but I need you to know these steps just in case they come up. It's something we talked about. We did it by hand a couple times, but then we said, hey, we can use formulas. We can use Excel and say stdev.s for our formula and then put our numbers in, or we can use Desmos, and Desmos has an stdev function. So there's a standard deviation function in Excel or in Desmos as well. So let's talk about the process. First, we compute the mean of the data set. That's what we'd have to do first. And then we find the deviation from the mean for every data value by doing what? Well, by subtracting the mean from the data value. Okay, so if we want to find the deviation, that's to say how far away from the mean it is. So we subtract the mean from the data value. And then the next thing we do is we square each of those. We find the squares of all the deviations. That would make them all positive. Okay, so it doesn't matter whether we were off on the low side or high side. And then what we do is we add all of those together. So we've found our deviations by subtracting, then we square it, and then we add. So we subtract, square, add. The next thing we're going to do is we're going to divide the sum by, and this one is n minus 1, okay? N minus 1, or the other way to say that would be the total number of data values, n, the sample size, n, minus 1. We subtract 1. The next thing we do is we need to do one last thing, because what we found at this point is the variance. But we need to find the standard deviation. So we have to square root this number. So an example would be that we could go ahead and do this whole process. But I want to tell you, rather than do this whole process, we use the stdev.s formula in Excel and type those numbers in, and then it will give us a number. We don't have to do all those many steps. We just need to remember which formula we're using in Excel. Now, I do want to mention if all the sample values were the same, if we plugged in, for example, 3333333 and then press enter in Excel, what do you think the standard deviation would be? Well, how much does it deviate? If they're all the same, then there's zero deviation. So the standard deviation would be 0. Using this frequency table on the left, I want to look at which histogram is the best fit for this. Now, histograms are kind of like bar charts, except they represent data that is quantitative on the bottom. In other words, they're numbers, and they're numbers that have kind of like breaking points. So each one of these represents a bucket that we're going to fill up. Now, this one hopefully isn't too scary to you because we have the number 0 for our smallest group from 20 to 29, 0 actors. And that one has 0 actors, but I want you to notice this one does not have 0 in the first group, okay? The next thing we're going to do is we're going to look at the end. Now, the smallest, it seems to get bigger in the middle, and then it tails off. So if I were kind of like sketch a graph of what this would look like, I'd say 0, and then 10, and then 14, and then 6 would be less than that, and 3 would be less than that, and 2 would be like that. So I just really quick was able to sketch representative of what this should look like. And so I think there's one that looks just like this. Okay, I think it's this one. You notice that the other ones kind of change directions on us, and so they throw us off a couple times. When we're looking at data in a table and we need to convert it to data in a graph, we need to be able to choose the data table and graph match that makes the most sense, okay? And so let me give you an example here. This example, we have years as our dependent variables, so that's along the bottom. And you'll see that that's actually true, right? It's along the bottom of both of these. Both of them are years, okay? And then we also have a median age, and both of them say median age. So I want you to notice first off that the data is right. You don't need to go zooming in here. Obviously, we can see that out of these two, the data is right. And so that's the first thing you need. If you're going to have a good graph, it's got to be the right data, okay? Obviously. The other thing we got to watch out for is, did we pick the best graphical display for our data? And if we have years on the bottom, if we have years, or if we have time, we're going to usually use that right there. So if time is our independent and we're showing a change over time, we generally don't use bar graphs, okay? So the question would then be, well, when do we use bar graphs? Because I feel like a lot of times we use time as our thing. Well, we use that when we have categorical data. In other words, is our independent variable, or is our X a category? And in this case, it's not really a category, it's a time. So it's showing, it's a number, it's quantitative. But if I had to split it up into, say, different groups from different countries or from different teams, then those are different categories, not the same group across time. A set of data items is normally distributed with a mean of 20 and standard deviation 9. Convert 16 to a z-score. So for this, we're going to need our z-score formula, or we can use standardize. As if we're doing it in Excel, we could use equals standardize, and we could give it those three numbers, 16, 20, and 9. But I'm not going to do that. I'm going to do it by hand because I want you to see it. Z-score, the formula is x minus mu over sigma. So if you know what each of these are, the x is the test score, the number that we're testing, 16. Mu is our mean, and so that's 20. And sigma is our standard deviation of 9. So we're just going to type those in and see what we get. So if I type them in, I'm going to type in my calculator here. I get 16 minus 20. And then on the bottom, I'm going to put 9. And I got a z-score of negative 0.44. for repeating. So I'm going to leave it just like that. A data value in the 80th percentile. Now, if we have a percentile table, this is the one that they were using in the book here. So we have the 80th percentile. What we want to look for is we want to look for 80th percentile in our table. Now, 80th percentile is pretty close to right here. So we can say that our z-score is at 0.85 for A. Our next one, it says find a data value in the 60th percentile. So we look for 60th percentile, and that is right about here, pretty close. So for B, we're going to say a z of 0.25. And the last one we need to do is 54th percentile. Now 54th percentile, where is that? Oh, that looks pretty close to right there. So I'm going to say C, the z would have to be 0.10. Suppose you study family income in a random sample of 300 families. Your results can be summarized as the mean family income was $47,000. The median family income was $32,000. Notice that the mean and median are different, and the highest and lowest were $253 and $2,300. So we need to look at these, and they all have the highest and lowest, $253 and $2,300. They all start and end there. So that's not what this is about. This is about the mean being 47 and the median being 32. And so since those are not the same, what we don't have is a symmetric data set. If it was symmetric, those would be the same. Now, also, this is also symmetric because it's flat. And I don't think that represents the situation either. So the question we have is, which way is this skewed? Do we have a lot more people that make less money, or is there more people that make more money? And so what can tell us this is the median. We want to know where our median is. And so our median in this case is 32,000. And so that's closer to the left. Our median is going to be where we see that big hump. That's going to be our median, okay? And so our median is going to be lower. Our hump's going to be on the left. And our mean is being pulled by the outliers. So the mean is being pulled by the families that make a ton of money, is pulling our average to the right. Decide whether the following statement makes sense or does not make sense. Jack is in the 50th percentile for height, so he is median height. That is, yeah, that makes sense. That's actually what 50th percentile means. It means 50% below and 50% above. Assuming that a set of test scores is normally distributed with a mean of 80, so the middle is at 80, and a standard deviation is at 5. So what that tells me is enough information to use a little bit of standardization to go. I'm going to go standard deviation of 5 means I'm going to go up 5. So this would be 85. And I'm going to go down 5. So that would be 75. Now, let's run through a couple things here. The 68, 95, 99.7 rule just says, hey, I need you to understand that, one, if it's normal, it's symmetric. So the first thing we might notice is that half of it is less than 50. Okay? That's the first thing we might notice. The second thing I want you to notice is with the 68, 95, 99.7 rule, that if we go plus or minus 1 standard deviation, that right there is 68% of the data. So if I were to ask what's between 75 and 85, that's 68% of the data. Now, if I were to go a little bit further, instead of going plus 5, minus 5, what if I were to go another 5? And I were to go all the way to 90 and all the way to 70. So how much is between 90 and 70? Okay, so since we've gone plus or minus 2 standard deviations, we say that our answer is 95. And then you'll notice that if we go all the way out to 95 and 65, in other words, we go plus or minus 3 standard deviations, well, then that big amount is going to be 99.7. Scores on this quantitative portion of an exam have a mean of 572 and a standard deviation. So they give me a couple things. They say that the mean is 572 and a standard deviation of 148. And it says what percentage of students taking the exam scored above 690. So what we're going to do is we're going to take our x is going to be the 690. That's what 609, sorry. That's what we're looking at here. So we need to convert that into a z-score. So we're going to say z equals 609 minus 572 all over 148. I'm going to type that in my calculator and see what I get. I got a z-score of 0.25. Okay. Notice I didn't get a negative. I just got a 0.25. So what I want to do is I want to look in my z-score table to find that z-score. And that's not too bad. I actually found it already. It's right there. And so it gives me a percentile of 59.87. Now the truth is that that percentile is the percentage below. And the question asked, what is the percent above? So we're going to have to say, subtract from 100 minus 59.87. And that would give us about 40% above. Add any questions in the comments below.